So, so all of you have joined the last week also. So I need not to be introduce myself, but by rules, I have to introduce. So I am SRIPAN. I am working as PMRF at IIT BHU, and this is one of the deliverables of the PMRF scheme that I have to conduct this type of live sessions. Right now, I am conducting live sessions for fluid dynamics for astrophysics, for which all of you guys are enrolled. So this is the week 2, and we will continue our discussions on different topics of fluid dynamics. So as we saw in the last week, there are some fundamental basic questions related to fluid dynamics, and uh, now we can move on to the Euler equation and the mass continuity Bernoulli equations in this week's questions. Okay, so let's move on to our first question. Just a second. Yeah, it's recording. Okay. So uh, this is a assertion that the flow of fluid is said to be steady if at any given point uh, along the flow, or so the velocity of each passing fluid particle remains constant. Now what does it mean basically? So when we can call a flow to be steady, so let's say you have some streamline flows, or okay, so let's say in this way some flow is going on. Now what is a steady flow is, let's say we have different velocity at different points. Let's say this is A and this is B. Okay, now this is, let's say, V1 and this is V2. Okay, now the thing is, since we have some different difference in the velocity at different points, whether we can call it steady or not. So the answer is yes. The steady depends upon the change in the, whether there is any change in the velocity at a particular point with time. So if in case of any flow, even if the velocity is different in different spatial locations, but if at particular spatial location the velocity is remaining constant throughout the timing of the flow, then we can tell the flow is a steady one. Okay, now the assertion is correct. Now the path taken by a fluid particle under a steady flow is a streamline. Now you see, this is also correct, right? The path taken by a fluid particle under a steady flow. So what do we mean by streamline? Streamline also has the same definition, that at each point of its streamline, the velocity should have a direction and direction as well as the magnitude, which will be unchanged with time. So both of the assertion and the reason, both are correct, but whether the second one, whether this is reason of this assertion, that is not correct, right? Because this is most likely the phenomena, and this is a terminology just related to that part. Okay, so this is not a reason, right? This is not a reason. Okay, so both statements are individually true, but the statement 2, which is this, is not the correct explanation of statement 1. So we have this property of a steady flow, and we also called that type of the trajectory followed by the flow of the fluid particles to be a streamline. But this streamline terminology is not the reason of this assertion. Okay, I think you guys got it. So this option B is correct for this answer. Okay, Hello.
One question, sir.
Yeah.
So here, a flow is steady in the sense that if you have the velocity field given to you, right? If
Yeah.
you differentiate it partially with respect to time and that derivative is zero, then
Yes.
the flow is steady. Is that true?
Yeah.
Okay, and if there is a time dependence, then the flow is definitely unsteady. Is that also true?
Uh, yeah. It should not be steady flow at all.
Okay,
Yeah.
fine. Okay,
Okay.
thanks.
Okay. Just a second. Yeah. So the next question is, which of the following are correct? So streamlines can intersect with each other. Streamlines are parallel to each other. Fluctuations in density is negligible when length scale of considered flow is less than gravitational scale height. Fluctuations in density cannot be neglected. So, can anyone help me to answer this question? According to you, which of the following are correct?
I think it's 1 and 4 that is correct.
1 and 4, that is correct. So, okay,
I think it's 1 and 3.
so you guys are saying that streamlines can intersect with each other. Is it so?
Yes.
So, okay. So in steady flow, what happens is at each point there is a particular velocity, right? And that velocity is does not changing with time. So it has a constant direction as well as magnitude. Now, let's say these are two streamlines. Now you guys are saying that okay, I have this streamline, I have that streamline, and they are intersecting with each other. Just a second. So one is okay, second and third is correct. Okay, so so what I am telling is, let's say there is a point in which they are intersecting. Now, what is the direction of the velocity along the streamline? So it is the tangent at each point along which, if it is this, then the velocity will be like this, right? So in this point, what will happen? There will be two tangents, right? Here is this and that is this. So at some point there is two direction of the velocity, and that is not possible for a streamlined flow. It is possible if it is turbulent. Turbulence is there, but streamlines are due to streamlines are connected to steady flows, right? And you cannot see that kind of a turbulence in a steady flow. It is going like a steady streamline, right? So you cannot have two different direction of velocity at a particular location. So streamlines cannot intersect with each other, because so what else option we have? So streamlines are parallel to each other. Obviously, if they are not intersecting at any point, then they should be parallel to each other, right? So this should be a correct answer. Now we have left with 3 and 4. So fluctuations in density cannot be neglected. So in the first place, you can tell that okay, it might be correct, right? But uh, okay, by means of fluctuation, I am saying about the spatial fluctuation, not the temporal fluctuation, because if you have the compressible or incompressible criteria, then you see that del rho del t is 0. I am not talking about that. So if the density within the flow, whether that is homogeneous or non-homogeneous, right? That is the point. Now, do you know about the Boussinesq condition or approximation?
Yes.
Yeah. So what does it tell?
That the rho g terms
Yeah.
are never neglected in any flows, right? That is the essence of Boussinesq approximation.
Okay, but that also has another consequence, that if the gravitational scale height is higher than the length scale of considered flow, then you can neglect that fluctuation also. Because what does it mean by gravitational scale height? So first thing is that, let's say you have rho at some point and it is changing as exponential minus, let's say, some x divided by h. Okay, this h is called gravitational scale height. Okay, g scale height. So you see, when you go by some difference in the location, which is h, then the density falls down as or change as rho naught by e, right? So this is a location over which the density is changing by a fraction of 1 by e. Now if you have the length scale of the considered flow that is less than this, okay, then you can think that okay, the fluctuation in the density is negligible. Okay, so now if you have this, let's say if you have x some length scale which is greater than h, what does it mean? It is already it is already changed by 1 by e times, and if you go further, then this will change much more than this, right? Rho naught by e. So your density cannot be uh, constant throughout the volume if you have a length scale which is greater than gravitational scale height. Fine, but if you have this x which is less than h, that means you have very small length scale, then you can tell that okay, we cannot measure the fluctuation in density. Okay, so I think this is also a part of Boussinesq's condition. What you are telling about the rho g, that is obviously correct, but you have two things here. First one is the grad p term, right? That is the change in the pressure gradient basically. So this one has to be 0 if you are considering some steady flow, for example. Okay, now from there you can find out this kind of equation for pressure also, that after some height or after some length scale this pressure will fall down, but till then you cannot neglect the fluctuation in density itself or pressure itself. Okay, so I think it's clear. Hello.
I had this question on the streamline.
Yeah.
So if I consider a turbulent flow, so turbulent flow in there, the streamlines will intersect, correct? And 2 is correct. According to me, 2 should be correct only when we consider a special case of a laminar flow, maybe, for example.
No, see,
So I'm
what
still
basically streamline flow is related to steady flow itself. Whenever there is some turbulent flow, you cannot term those trajectories followed by the particles as streamlines. Okay,
okay.
so that's the case. I think it's okay for
Sir.
now.
Sir, one more question about the streamlines.
Yeah.
Okay,
Huh.
so let's consider a steady laminar flow. Okay, now
Mhm.
streamlines are defined. Yeah, now in this flow, insert a sphere.
Okay.
Now, as the sphere is inserted on the boundary of the sphere, where the liquid is overtaking that and just going above it, all of these streamlines have to intersect there. And now, like the contradiction in your example where you drew those two lines which are intersecting, right? If the tangents occur to be the same at that point, which can also happen, right? Like you can think about two curves which are just touching the x-axis and going back, something like that. So, like the curves may be different, but they intersect just for a point and then go back, such that their tangents are the same, which could happen, right? And then the velocity is still different.
See, at that point, for a particular very small time scale and very small length scale, you have a turbulent there, right? Whenever there is some like a sphere is there and some streamline is going in that direction, let's say you have the tide in the sea also, so whether that is streamline at all, so that has some specific profile, some very transient flow, right? So that has some turbulence associated with it. It is no longer the steady flow at that particular position, but we are concerned about the more general case, that okay, in a more uh, I mean long time scale or long length scale, whether there is some turbulence, whether there is some intersection between the streamlines. You are giving us some very specific case and very specific time scale which is very short. Okay, so for that, yes, those can intersect, but in that time, whether they are streamlines or not, they are not streamlines, they cannot be tell, right?
Oh, okay, okay. No, I thought like in the lecture actually you had mentioned that this around the sphere we can calculate the what is that called? The velocity field, and then we have everything. Like even once we have the velocity field, it's all defined, right? He, I
Yeah,
think he uses some
so
sort of
velocity
approximation.
field can be calculated, but that does not mean
Hmm.
that that should be a streamline itself every time, right?
But sir, like the streamline was a curve which was defined by that ux by dx equal to uy by dy,
Okay.
right? So if you
Huh.
have the velocity field, then we have the streamline.
So every time you were saying that whenever you are able to determine the velocity field, that should give you a steady flow, is it?
Okay.
That should not be right. I mean, even if
Oh,
there
you
is some
mean like that?
turbulence, whether you will be not able to uh, determine the velocity.
But then, so like it's like if you have a turbulent flow, then the velocity field won't be a function, right? Like the okay, it will be a function, but I mean the velocity is changing way too quick, and then you have like two different. Yeah, it won't be a function actually. Yes, you can have like intersecting streamlines, so to speak. Even though streamlines aren't defined,
Yeah.
you could have like intersecting things, and then velocity is pointing in different directions, and it's
Yes.
just changing over time very quickly.
Yeah.
So it won't be a function itself. So there's no meaning to defining anything about the velocity vector in that case, right? So, like, whenever you can define a proper function as a velocity field, then I think we should be able to do this, right?
Okay. Okay, I will think about it. I think.
Okay, sure.
Okay.
Thanks.
Fine. So, for the time being, let's move on to next question. Okay. So, is this great question visible to all of you properly?
It's small for me. If you can zoom in a bit,
Yeah.
it will
Okay.
be.
So now it's okay, right?
Yes, yes.
So it's asking for which of this is the non-conservative differential form of Eulerian x momentum equation. What does it mean by x momentum? Is the x component of the momentum. So first of all, we need to remember what is the Euler equation, what is the form of it, right? And another thing is what is non-conservative or what is conservative form. So can anyone tell me what is conservative, what is non-conservative form?
The conservative form is you take the quantity, take a time derivative,
Mm-hmm.
and you sum that up with the gradient of the flux, and that
Okay.
should equate to zero.
Yeah.
That is the general form of a conservative
Okay.
equation.
So basically, when we have the, let's say, mass continuity equation, what we have is del rho del t plus divergence of rho v, where rho v is the mass flux, right? So this is a conservative form. Now similarly, for the momentum equation, you can have del t of rho v, the change in the momentum itself, momentum density basically, plus gradient of the flux will be of the momentum. So this is momentum, and you have a outer product of velocity. So that should be. Now if you have some source term, let's say minus grad p plus some rho into some force, which is, let's say, a body force. In general, it can be a gravity force. Okay. Now if it is written in this form, as you suggesting, this is the conservative form. Now you want to have the non-conservative differential equation. So first of all we need to think that how should we write the Euler momentum equation in the non-conservative form. So if you go through some calculation here, you will lead to this equation, right? Rho, let's say this is del v actually, so del v del t plus there should be a term like v dot grad and v, right? There should be a row right here, I think so. Okay, so this is minus grad p, this is rho f. So this is Euler equation, right? I think, yeah. So there should be a row form also. Okay, is it correct? Hello.
Yes. Yes.
Yeah. So this is in non-conservative form, right? This does not resemble this kind of a structure. Now what we have, we need to find out the x component of this equation. So how do we find? So let's say rho, okay, so for more assurance what we can do is, here you see, if you remember the material derivative, right, the material derivative what it suggests is this del u del t plus this term, what it tells, this is du dt, right? Okay, and there should be a rho, and that should be equals to minus grad p plus rho f. Now if you have, okay, now if you go to the x component, what we have is rho dux. Let's say if the x component is x, that should have this equals to, its x component will be minus grad del p del x plus rho the x component of x, right? So what will be the correct answer? I think this B, right? This one. Fine. Hello. Hello.
Yes. Yes.
Yeah.
So is there a typo, because in the options I
Yeah,
don't
there
see a
is.
UX.
There should be some x, right?
Okay.
Yeah.
Okay. Mhm.
Okay. So, okay, let's move on to the next question. So, yeah, this is the similar thing. The calculation has been done here. Now, this is the next question is, which of the following are incorrect? So, the first option is both gravity and pressure force are surface force. Stream function is conserved around streamlines, and equipotential lines and streamlines are parallel to each other. So tell me what are the incorrect options.
1 and 3.
1 is incorrect. 1 and 3 is.
Okay, what is incorrect about one?
Gravity force is not a surface force; it's a bulk force.
Okay,
And for the 3, they should be perpendicular. They should not be parallel.
okay. So can you tell me what is a stream function? What about the equipotential line, and how can you tell that they are perpendicular to each other?
There was this equation del phi dot del the gradient
Okay.
of phi dot that gradient of stream function equal to 0.
Yeah.
So
So fine. So you have two equations, right? Let's say we have to start with, we can have a incompressible solution, what is divergence of u is 0, right? This is equals to, now it is happening only if the velocity function is defined as some function, some curl of, right, that is psi, or some unit vector, let's say j, right? This psi is known as the stream function, correct? Stream function. And also you have another equation which is for e-rotational flow, that gives you this equals to, sorry, this is equals to, so this should be what? U is derivable from some, right? So you see that the gradient of phi, this is the potential, right? So this is the potential, okay, just a second. Yeah, so okay, yeah, so this is the potential. Now you see you have, just a second here. So you have a potential from where you are deriving the velocity. So the grad phi will have a direction which will be in the same direction of u, right? Grad phi is parallel to u, and from this you find out that grad of psi z, now psi is directing in some direction followed by some z, it might be some arbitrary direction, but when you take a curl of that, that means the psi itself, right, psi j itself is perpendicular, right, to u. Fine. Now from these two equations you can solve yeah, so from these two we can see that there is some equipotential lines which are given by phi, and there is some stream function which is along the streamlines. Both will have some perpendicular relation in between them, okay? So okay, and the other thing is the stream function is conserved around the streamline, that is also correct, but this should not be a correct answer as gravity is a body force, okay? Fine. Someone is writing something in chat box. Okay, Sachin. Fine. Now let's move on to the next question. So we have, so suppose a wheel is moving with the flow of a fluid governed by velocity, there is some velocity given. What will be the complete description of its motion? So what is it, the question is saying is, you have some flow, some velocity field is there, and you have a wheel in between that which has some motion in the with the flow. So whether this is only the translational, this is the translation, or there can be any extra kind of motion associated with this wheel. So what extra motions can be there? First of all, we need to find out what can be the other options for this wheel except the translational motion. Can anyone tell?
Rotation will be one.
A rotation can be now. Rotation is depending upon which property of the fluid or anything.
It will depend on the viscosity of the fluid.
Okay, now
If there is a
viscosity depends on the velocity gradient, right?
yes,
Okay, so and another thing is there, right? If it is inviscid, it it has to be the irrotational also, right? Because if the velocity field is like the straight lines, then there should not be any like when you have viscosity, that means you have some extra velocity in this direction which is taking this wheel in some this type of direction, like this is the rotation. And when you have a layer which have some lesser velocity, then comparative to this pull or this dragging is less, so as a result this is rotating, right? So basically due to viscosity you can have some rotation. Now given a velocity field, what is our point? How can we solve that whether there is some rotation or not? Because we don't have any information about the viscosity given in the question. We only have a velocity field. So how should we determine whether there is some rotation associated with this motion or not? Can anyone tell me?
We need to find the call of the velocity field.
Field of the velocity field. Okay. So can you guys solve it by yourself and tell me whether there will be any rotation or not? So what you just basically have to do is you have to take this. Let's say u is given as a function of u, x, y and z. From there you have to find out the curl of u. Okay, so if it is equals to 0, then it will be only translation, and if it is not equals to 0, then you have translation plus some rotation, right? So kindly solve it by yourself and tell me whether what is the complete description. Okay,
I found call is 0.
curl is 0, so it should be no rotation, right? Only the translation.
Yes. Yes.
So another thing is that as I already mentioned, that if you have some irrotational flow, that means there is no velocity gradient also, right? And that means the fluid is not viscous, it is a inviscid fluid. So okay, let's move on to next question. Okay, this is just the solution. Now you have the Navier-Stokes equation describes the motion of solid substance, non-viscous fluid, viscous fluid or gas. What is the correct option in this?
viscous fluid.
Okay. Now what is the difference between a Navier-Stokes equation and Euler equation?
We do not consider the viscosity when you derive the Euler equation.
Okay, so
We
Navier-Stokes equation is a more general thing in which if you neglect or not consider the viscous term or viscosity or drag, then we are telling that that is a Euler equation, right? Okay, so fine, this should be the viscous fluid. Okay, now the next question is, if the velocity is at 2 points and pressure at only one point of the streamline is known, so you have a streamline, you have 2 points, right? You have a streamline, you have 2 points, let's say A and B. Now if you know the velocity VA and velocity VB, and you know only the pressure at PA, then how to find the unknown pressure at the other point of the fluid? So how should you find the PB in this region or the point or B? So tell me what is the correct option for this. Hello.
So by using Bernoulli's equation, we can do that.
Okay, so what does it mean by the Bernoulli equation? Is it depending upon some conservation of some quantity, or how do you
Then
find the Bernoulli equation?
it is based on energy conservation principle.
Energy conservation, right? So we have this type of form, right? These are P plus half rho V square plus rho G H. This should be a constant. This is the Bernoulli equation. Now if you have a straight line, and if we consider that okay, at these 2 points the H is the same, then there should be any change in this potential energy term, right? The only changes can be at the pressure and the this term, which is kinetic energy. So if you have some information about the velocity at these 2 points, you can easily find out the pressure at the second point if you know the pressure at the first point by the Bernoulli equation. Okay, so this is just an application of Bernoulli theory. Okay, the next question is about, so Bernoulli equation is derived based on the following assumptions. There is no loss of energy in a liquid flow and flow is steady. The flow is rotational except gravity and pressure forces. No external force acts on liquid flow. The flow is viscous, incompressible. So which are applicable? Tell me. Hello.
I think there is no loss of energy in fluid in liquid flow. Flow is steady,
Okay.
and I can and number 3, that is except gravity and pressure force, no external force acts on liquid flow.
Okay. And the what about other students? Whether this is correct? What he is saying? Hello, are you guys here? First and third, Sachin is saying, okay, fine. So yeah, that's correct. This is the first one and the third one. Okay, now the next question is, so this is some numerical question here, so you have to calculate. Just have a try. So you have a nozzle with a diameter of 0.5 centimeter, which is attached to a garden hose with a radius of 0.9 centimeter. So you have a diameter, you have a radius, and you have to find out the flow rate through hose and the flow rate through hose and nozzle is 0.5 liter per second, which is given. So flow rate is constant throughout the flow, and calculate the speed of the water in the hose as well as in the nozzle. Now, without calculating the answer, if we just ask that what will be the difference between the speed of the water in the hose and the nozzle, whether the speed of the water is high in the hose and low in the nozzle, or the vice versa. So how can we tell that? So can anyone tell me? You have a constant flow rate, you have two diameters or two radius given which are different from each other. How do you find out the speed of the water given that the flow rate will be constant in different diameters? So first of all, what is a garden hose is, uh, it's used for giving water to plants in. Okay, sir, are you uploading this lecture somewhere on YouTube as later? We need to cross check. Yeah, it is uploaded in. It will be uploaded in YouTube. So you guys are not able to see the first week's lecture later. Is it not shared from NPTEL team?
No, sir.
Okay, still now this is not shared. Okay, fine. I think they will share it because I mean, I have shared with them also the link, the YouTube. So generally, they will be responsible for sharing to all the students through some instruction or something. So okay, I think they will share it soon. Fine. So we have this question. So can anyone tell me what will be the difference in the speed in the hose and nozzle? I mean, which will be higher, which will be lower?
Higher the cross-sectional area, lesser will be the velocity.
Higher the cross-sectional
So,
area, lesser the velocity. Yeah, correct. So, so at the nozzle,
so
the velocity should be high, right?
higher. Yes.
Okay. So, can you do it by yourself? Okay, I am giving some hint for everyone. So what we have is, let's say, some flow rate, flow rate, which is q. So just join me. Yeah. So there is some flow rate which is q, and now having a look at this dimension, you can find out this there is a liter per second. That means some volume is going with some second, right? Now you have from this equation is, let's say A is some cross-sectional area, and if you multiply the velocity, that should give you this flow rate, right? So if you have some length scale here, that will give you some volume, and length scale per unit time, that is the velocity, and so A into V is giving you the flow rate. Okay, now as someone is suggesting that if A is higher, V should be lower because the flow rate is constant. So using this formula, you can easily calculate the velocity at two different points, right, at in the hose and the nozzle. So the catch is you have to find out the cross-sectional area here, right? So how do you find out is, so these are both cylindrical kind of shape, the nozzle as well as the hose. Okay, so you can just find out the cross-sectional area as pi r square. Okay, where you have the r to be radius. Now can you calculate by yourself and tell me whether this answers are given correctly or not? Is someone trying by you? Just give some assurance that you guys are trying. Aditya, Sumit, Amit.
I am commuting, so I do not have anything to try on. So I'm just noting things down somewhere on an audio device. That's it.
Okay. And the spin 2 Riti. Okay, fine. So let me share the solution here. So see, you have the flow rate, so which is PA. So I have calculated for one only, the other can be calculated in the same uh, way. So what it tells is you have the flow rate given, and for that you have VA, so you have to find out the V at the nozzle. So you have given the 0.5 liter per second. You have to take everything in SI or CGS. I prefer to take in SI. So this is meter cube per second, because 1 liter is, or 1 meter cube is 1000 liter. So that means you have pi into d nozzle by 2, because this is given the diameter. You have to divide it by 2 to get the radius. So pi r square is there. So if you calculate this, you will find out this is 25.46 meter per second. So this is essentially this, and the other thing can be calculated in the same way. Okay, I think it's clear to this is pretty straightforward problem. Okay, any problem? Hello.
None from my
No,
side.
sir.
Okay, fine. Let's move on to next question. So there is another problem here. Have a try. Water flows at a steady velocity through a horizontal pipe with a changeable diameter. The water velocity is 2 meter per second and pressure is 2.5 kilopascal at point A. This is some point, and the pressure drops to 1.5 kilopascal at point B. What is the water velocity at the point B? Again, this is another application as the previous question, that we have to calculate the water velocity at a different point, given that we know the pressure at both points and velocity at the other point. So just apply the Bernoulli equation here and tell me whether which one of the is the correct answer. Yes, it is shown here that root 6 is this, but we should calculate it to confirm whether this is a correct answer or not. So are you guys trying?
Yeah, just 1 minute.
Okay, have a try. So writing something. Okay, fine. We try. Any progress from anyone? Here you have to consider the height as the same because it is a horizontal pipe. So you need not to calculate or bother about the potential energy. Only things are the kinetic energy and the pressure force. Right? So what it is basically?
How do we get the? Oh, okay, sorry, it's water.
Sorry?
Nothing. I thought it was some other fluid. I didn't know the density. So.
No, this is water. Okay. So this is PA by half rho VA square equals to PB plus half rho PB square, right? You have given this PA, you have given this PB, and you know rho can be taken as 1000, and now to find out this VB, right? VB is what? Okay, I'll just calculate. So yeah, Sachin, any progress? 5. So taking the second one.
And the answer is 3 to the power 0.5.
No, it will be root 6. So this is 6 to the power 0.5, I think. Let's wait for the others.
Yeah, it is. It is root 6. Yes.
Root 6. Sachin is telling root 6. Dhriti, are you getting it? Amit, Anup.
Yeah, yes, that is the root over of 6.
Okay. Okay. So let's have. Okay, someone is writing. Dhriti is writing 6. So I think you are getting VB squared is 6, right? Then it should not be 6. It is root 6. Okay. So okay, let's have a look at the solution, even though everyone already solved it. So first thing is that you have this equation of Bernoulli, which is telling that the energy should be conserved. So you have this has given. So you have Z at ZV is same because it is a horizontal pipe. So you have to just put the values in this, and you will get that VB is root 6 meter per second. Okay. Okay. So I think this is the final question. So you have a fire hoses used in major structural fires have an inside diameter of 6.4 centimeter. This is the figure. Okay, so it has been used to extinguish fires in some buildings, high buildings, let's say. So suppose such a hose carries a flow of 40 liter per second, starting at a Gauss pressure of some quantity 1.62 into 10 to the power 6 Newton per meter square. So the horse rises up 10 meter along a ladder to a nozzle having an inside diameter of 3 centimeter. What is the pressure in the nozzle? Okay. So first of all, one term is here which is Gauss pressure. Gauss pressure. So can anyone tell me what is Gauss pressure? You know about pressure, but what is Gauss pressure? How it differs with the normal pressure? Anyone knows? Anyone? So you know about the atmospheric pressure, right? So let's say you have some pressure which has some value exceeding the atmospheric pressure. Now that excess value or excess amount is called the Gauss pressure. Okay, let's say you have some pressure P. Okay, now that should have some value which is greater than atmospheric pressure. Let's say this is atm, right, plus the gauge pressure. Okay, so it is the difference between the exact pressure and the atmospheric pressure. Fine, this is gauge pressure. So it means you have a pressure which is higher by this amount than the atmospheric pressure. Okay, now this is again application of Bernoulli theorem. So what we have is, this time we have a 40 liter per second flow, okay, which is constant throughout this flow, and you have two diameters. One is given as 6.40 centimeter, or another is this one, which is 3 centimeter at the nozzle, and you have 10 meter of height in between these two considered points. Okay, so what we need to find out is what is the pressure in the nozzle. Okay, this is your question. So again, this is just a simple application, but this time you have to consider also the rho gh term, right, because there is a change in the height also. There is a 10 meter change. Okay, so this time you can have this equation as p plus half rho p squared plus rho g h equals to constant. Now you may ask that how to find out the velocity in these two cases, right? Again, you have to consider that part, that q equals to a v, right? Now the q is given, which is 40 liter per second. So you have to find out the p, as you know, the a, the cross sectional area, because the diameters are given here, right? You can find out v by v equals to q by a. So you have v known, rho is known because this is water, and you know the pressure at some point, you know the h. So using these two formulas, you can find out the pressure at the higher point. Okay, so can you try? Aditya, Amit.
Yeah, trying one.
Okay, let's have it. क्लास चल रहा है. Pinto, are you trying?
Yes, sir. Yes.
Okay.
Sir, please do the visible the question.
Yes, yes. It's visible now.
Yes, sir.
Okay. Any update?
Just a minute.
Okay.
Sir, V1 and V2 will be 12.43 meter per second and 56.59 meter per second.
Okay. Then
Then just then we should put the values in the Bernoulli's equation. P
okay.
plus
So 12.43 second and
and then
56.59.
56.59 meter per second.
Okay. And to the other calculation and tell me. I will check whether it will same or not. Sachin, any update? Sumit is not doing. Anup, Aditya, anyone?
So I'm getting some 5 or something.
5.
5,000. No, wait. 1 second. It's not that. 1 second.
Okay.
Sir, please make the visible question.
Okay.
So I'm getting some positive 1.2.
Positive.
Not 1. Getting some in kilopascals. It'll be about 10 or something. So something is wrong. I made some calculation mistake. I think.
10 kilopascal.
Calculation.
So the given value is around how much? 10 to the power 6. So it should be 1 Newton per meter square is 1 Pascal, right? So this is 1 megapascal, and you are getting kilopascal which is positive value. Have you put the diameters properly in meter?
Yeah, I did that.
Okay, let's have a look. Maybe I can be also wrong, I don't know. So the velocities are okay, right? The velocities are already found. Thing, right? Velocity is okay.
Yeah, I got my mistake. That's the thing. I forgot the 10 to the minus 3.
Okay. So what I did is so basically we have started with the flow rate, and using the given value of the diameters at different points, I have found out the VA as well as the VV. As someone suggesting, these are the values, right? VA is 12.43 and VB is 56.59. Because to have a constant rate, you should have maximum or greater velocity when the diameter is smaller, right? Okay. Now after that, what I did that you have the lower point which I termed as A, and the higher point is termed as B. So using the Bernoulli theorem, what I did is I have put all the values which the question is suggesting, and also the velocity values which I have estimated through the conservation of flow rate. So all the values have been put in here, and using them I found out the PB to be minus 3961.6 Newton per meter square. So I told it that it is minus 3.9 kilopascal. So but it's subjected to some error also, because this is some thing which I calculated without any proper calculator, so I don't know if there is any mistake, but okay, you can check by yourself also. But one thing is clear, that the pressure at that high height should be very less than the pressure at the lower height, because to have a water flow in that upward direction, you should have a very high pressure at the lower height. That will push or that will drag the water to higher heights. Okay. Also, as I was suggesting, that Gauss pressure is nothing but the difference between the atmospheric pressure and the total pressure. So negative Gauss pressure means what pressure you are getting, which is that is negligible compared to your atmospheric pressure. Okay. Fine. You can check the value, right? I think there can be some calculation mistake. Someone please tell me whether it is correct or not. Sachin, Amit, Aditya, Adriti, anyone?
Sir,
Ah,
if I calculate the PA minus PB,
uh-huh,
just PA minus PB, not individually PB,
uh-huh.
then what should I do? That means PA minus PB. I have got 1.42 into 10 to the power 6.
PA minus PV is 1.42 into 10 to the power 6. Okay. Now you have the value of PA, right?
Yeah. I have the value of PA,
So
which is
you can get the
1.6.
value of PV.
And and and, what is the physical significance? Please repeat.
Yes.
Someone is telling something. Hello? Your voice is breaking. Okay, some physical significance of what?
Physical significance of this negative gauge pressure, that means negligible compared to atmospheric pressure. So
Yeah, basically what Gauss, actually this is not Gauss, I think it is Gauge.
yeah, gauge pressure.
Yeah, so I have written it in the wrong way. This should be gauge pressure. Yeah. So see, the gauge pressure is the exceeding or descending value of the pressure compared to the atmospheric pressure, right? Now, if you have some pressure value which is negligible than the atmospheric pressure by a 10 k power 3 order, right, thousandth of order, because this is kilopascal, then whenever we are saying about some pressure, we have some reference as atmospheric pressure, right? That is our reference point. Now whatever pressure we are getting here, that is quite less than our reference point. Basically we think that atmospheric pressure is a reference, and considering that as a reference we calculate, or we basically said that okay, the pressure is that much apart from the atmospheric pressure. But here you see there is a negative value as I calculated. So that means your estimated pressure is even 1000 times lesser than your atmospheric pressure, which is taking as reference. So you can tell that it's almost negligible compared to your reference point. Okay. So that is what I was
Okay.
telling. Yeah. So anyone got this answer or anything else? Aditya was saying he's getting some plus sign. I don't know. Anyone else?
Sir, please do visible the solution. I just
Yes.
want to
Yes, yes.
minus 10. Why this is minus 10?
This one?
Yeah. ZA cancel out, and the 10.
See, I have taken this PB minus this. So I have taken everything in this side, right? And that has been written in here. Now what I have is this 10 is going in that side. Fine.
Okay.
So you should have this minus 10, right?
Okay.
Yeah.
Just 10 percent. Okay. Side change.
Yeah. Aditya, are you trying?
No, sir, I was trying to find my mistake only. Actually,
Okay.
it's
What
too
about
much
others?
calculation.
Sachin, Riti, anyone taken -4? Okay. Yeah, I was also getting something like that, -3.9. Yeah. Okay. Fine. At least someone confirmed. So, what about others? Pintu, are you trying?
Yes, sir.
Okay. Just want to try and confirm. So this is the last question, so that's why I'm waiting for others to complete. Amit, any progress?
I'm doing right now, sir.
Okay. So Shivang joined just now, and the class is almost over. Hello, Shivang, are you there?
Yes, sir.
So, as the timing is not suitable for you?
Sir, actually, I was out for work. I just returned.
Okay, fine. Priti already answered.
These online sessions
Uh,
will be occurred in every weekend, Saturdays or Sunday.
yes, it's every Saturday. It will be from 5 to 7, the usual slot. But depending upon the speed in which we conduct the class, it depends upon myself and also your every students how you guys are responding. So it can go more than 2 hours or it can go just 1.5 hour also.
Okay, that means every Saturday 5 to 7.
Yes.
No, not Sunday.
No, Sunday.
Okay, but that means it will be up to the exam, before the
Yeah,
exam only.
total it will be run for 12 weeks. So also in the lecture you can see there will be 12-week lecture, right? And
Yeah,
every week you get an assignment to solve.
yeah.
So similarly, I have to take 12 live sessions with you guys. So just tell me whether uh, the assignment submission dates and assignment submission dates is earlier than this live sessions for a particular week.
No, it was just earlier for this week, I think. Week 3 is on 15th, if I'm not wrong.
Week 3 is 15. No, that's fine. But if it the week 3 is 15, then I have the live session and in 18, right? Again, that should be earlier.
Yes, 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 correct, correct.
So I don't know why uh, this way everything is set up, because we also told the PMRF team to start the sessions earlier. I think 3-4 days before, but they told that okay, we'll start by 3rd of February. So I don't know. So this somehow unreasonable thing. After the solving of solutions, you guys are having some session for that week. Anyway,
So are we allowed to discuss the assignment questions here, or should we use the
no,
discussion?
actually, what happens is, in general, we are told that we have been told to solve the assignments, but in for this course, what happens is, this is only running for the second time, okay,
Mhm.
in NPTEL. So they don't change the assignment questions from the previous year. So
Okay.
that's why we cannot discuss. So for that reason, we have to uh, make sure that we have to solve. We have to set the question by ourselves and also solve those. Otherwise, in different courses where the courses are running for 4-5 times, then they have that liberty to solve the previous year assignments.
Okay.
Yeah. So Sumit, you were not trying, right? You were just
I am commuting, so that's why that is a problem for my end.
okay. Fine. Amit,
So
hello.
is it possible to shift the time from 6 to 8 instead of 5 to 7?
Now that is in my hand initially, but right now it is not my in hand because it's already communicated to the team, and now even I don't have that liberty to shift the classes. Even if I have some problem, I cannot shift. So that's something, I mean, issue.
Okay.
Yeah. Okay, I think the class is almost over. So tell me whether if I need some improvement in terms of some, I mean, what type of questions should I discuss? Today there is so many numericals, 3-4, because it also depends upon the contents of that particular week. So depending upon that, I have set some questions because I cannot rely on the assignments itself. It's good to discuss with you people because everything is not. Can we do two assignment discussion? Two assignment discussion next week. So, are you asking for the assignments which have been given in the second week, which you already submitted, to catch up with our submission schedule? Two assignment discussion. It will be hard for me. I don't know. But again, if I take like that, then let me think. Okay, because I should get that time to make it. I will think about it and I will try. If I could do so, then it's okay. Anyway, it is taking almost 1 hour 20 minutes. So if I have the content by then, or can we go directly? No, because I have to submit these things to YouTube, and after that they will give some certification. So I have to consider, coordinate in that way. I don't have that liberty, sorry.
Sir, this live session will be recorded and it will be available to Swarm website.
Yes, I think so, because so basically what I have instructed is I have to conduct these live sessions. I have to take the recording of the entire session, and then I have to upload it in YouTube. And after
Okay.
that, I share the link with the NPTEL team. And after that, they are supposed to share it with all the learners for the course. I don't know why the first week's session is not shared with you guys till now. I have already shared the link 2-3 days back. This one also I will just upload today in YouTube, and I will share the link to them. Then it's up to them what they are doing.
Okay.
Yeah. So I think so any comment, like any improvement needed, anything? If not, I think let's end today's class, because I have not any content left for today. So shall we leave?
Yeah.
Okay.
So thank you.
Okay, thanks very much. Bye.